So welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is what is a digital twin? So let's try to answer the question of what is a digital twin. Even before that, let's try to answer the question of what is not a digital twin. What is not a digital twin? When this new modern concept being introduced into various research field, in generally what could happen, they often try to rebrand the existing models with this concept. So a similar thing happened to the digital twin also. So that is why I selected this question of what is not a digital twin. Rebranding of these existing models, I would believe, can create quite a challenges on the development side of the digital twin. So I would like to say it is not existing CFD code, it is not existing CAD drawings and so on. Because we need a new type of frameworks to be introduced to develop this type of a digital twin into various industrial applications. So you might ask the question, why not? The answer is because the existing such models cannot handle or facilitate extreme data. I have done another video on extreme data, so if you're interested in, I would put the link below to this video and you can go through that video to have an overview understanding of what is extreme data. But I would say a little bit on as a summary of the extreme data in this presentation. So here you can, in this figure, I am presenting mathematical framework of extreme data. It consists of various data clusters, and these data clusters can be normal data clusters as well as anomaly data clusters. Beyond these data clusters, there can be various data points being existing in such extreme data sets. So these data points may related to various data anomalies or outliers related to this specific system where these extreme data sets are collected. So let's try to answer the main question of what is a digital twin. Digital twin is developing system behavior from extreme data set. So these models or the digital twin models are related to the system through the extreme data set, but not through the first principle or classical mechanics based theories. That doesn't mean we are pretty much going to eliminate these existing domain knowledge, but rather we will incorporate this domain knowledge in a later stage into the digital twin. So the main component of a digital twin can be classified as a system, model, and extreme data. So let's talk about how extreme data will relate it to the development of a digital twin. So the utilization of extreme data would be done in two levels. In the first level, we would have extreme data for model development. These data sets can often be offline data sets. So these offline datasets will be utilized to develop the initial model of the digital twin. And in a later stage, we use the extreme datasets from online data, and then these online data will be utilized towards the update the existing digital twin models. So due to time varying conditions of these type of complex systems, when you have extreme data coming online, that would facilitate the model development in a somewhat highly accurate way. So that way the model can always get updated with respect to the varying system conditions. So let's try to answer the question of how to develop such digital twin models. So the answer would be machine learning. Here I am specifically referring to deep learning type of frameworks, including various type of neural networks. So if your question is why it is only machine learning, the answer would be because that's the only approach can handle extreme data sets. So when you're developing this type of digital twin models, you should always have model objectives, because these model objectives can make these models useful models. So these models will be developed for a specific purpose, and it would not be able to utilize towards every application. For example, if you develop a digital twin models towards ship energy efficiency, you would not be able to utilize the same models toward ship maneuvering. So as I have mentioned before, we are not moving away from the physical laws or the classical mechanics, but we are adopting that domain knowledge into the machine learning. So when we're deciding how the neural networks in this type of digital twin model should look like, the existing domain knowledge or the physical laws will be utilized to understand and develop such type of neural network structures. So that way you can think this machine learning approach with the domain knowledge can be like a supervised learning approach. In general, the limitations of the physical laws or the classical mechanics will be reflected on the model assumptions. Since we utilize these physical laws in the process of developing a digital twin, these assumptions will also play an important role in the development of a digital twin. So therefore, model assumptions going to be a part of the development process of the digital twin. And you should also remember that if there are any environmental constraints on this system itself, those environmental constraints will also come into this digital twin as model assumptions in its development process. So if you ask the question why digital twin is a superior approach, the answer would be the information richness in the extreme data can make superior digital twin models with compared to the existing first principle or classical mechanics based models. Inside these deep neural networks, this type of information can be preserved as vectors and matrices, so that an information preserving structure and the information itself make these digital twin models are far superior models compared to the existing models. So then you might ask, any limitations on the digital twin? Yeah, the answer would be the digital twin will be limited to the availability or the accessibility of the extreme data, since this is purely a data-driven approach while utilizing the existing domain knowledge. But I wouldn't think that would be a problem in the future. The main reason is most of these modern systems consist of massive amount of sensors, and then these sensors collect a large amount of extreme data. So that way these data sets eventually can be utilized to develop digital twin, and then while these existing digital twin models can be updated by the online data sets that are collecting in real time. So that way these models will always have a current conditions as the system itself, as well as the superior performance compared to the existing models. So that's the end of my presentation, and hopefully you have enjoyed this topic also. So if you are still interested, please stick around. Thank you.